Okay, so today we are doing scientific, hurry up, we are doing scientific notation. You're in our notes now. Pass in your homework. So let's go ahead and define what scientific notation is. It is a way to write very large or very small numbers. There we go. Good. Thank you. Okay, now, a number, listen, we're in our notes. A number is in scientific notation if it is written as a number between 1 and 10 and multiplied by a base 10. Well, here's what I mean. Let's say I want to write this number, 534,000, which isn't that big of a number. There really wouldn't be much of a reason to use scientific notation for this number. But I want you to watch what I do. Look up. Okay? In order to write, this is standard notation, by the way. This is standard. I look at the actual digits, and I'm just going to write them as a decimal between 1 and 10. So I'm going to write it as 5.34. You with me what I did there? Took those numbers. Okay. Now, the decimal point is actually right here. I'm going to count how many places I moved it. 1, 2, 3, 4, 5. I moved it 5 spots to get it right there. So this is times 10 to the 5th. Go ahead and write that.
And what did you mean by standard?
Standard, this is like how you normally write a number, right?
Okay.
So that's standard notation. This other one over here on the right, that's scientific notation. So what we're basically doing today is we are changing to and from scientific notation. We'll also do some multiplying, I think, of scientific notation because it's not that difficult. All right, take a look up. Look up. All right, so here's a standard notation number. I'm going to write that in scientific notation. So I need to express it as a number between 1 and 10. So the first thing I'm going to do, though, before I get going, is I'm going to add my commas. So we add a comma every 3 decimal, or every 3 places. So 3, 3, and I'm just using those to help me count. Because I don't want to get, if I do this hump counting here, like I might easily skip over something. So that's just extra stuff. All right, so I get all my important digits. Those are those 3 right there in front. You with me? All right, so I'm going to write that as a number between 1 and 10. So that's going to be 6.07. Now it's times 10. Now I need an exponent here to tell me how many times I move my decimal point. Well, 3, 6, 9. So 10 to the 9th. Any questions how we did that? Okay, let's do one more. Let you get that down. So all we're doing, and why this times to the 10 to the 9th works is like really this is how many decimal places or how many base 10. Like this digit right here, that's 10 to the 1. This digit right here, well, that's 10 to the 0. This digit right here is 10 to the 1. This digit here is 10 squared because it's 100. this is 1,000, right? So that's 10 to the third. So that's why we do that. We tell which decimal place this is at. You with me? Okay? So our number system is base 10, so that's why we have times that 10 there. All right, so let's say we have I'll give you the commas. Okay, so those are all zeros. All right, so that's not a comma right there. All right. In scientific notation, so there's like only one number, right? That 9, right? So I have a 9, so 9. Now I could add a 0.0 if I want. It's not necessary. Times 10. Well, how many places did I move my decimal point? Well, 3, 6,
9.
9, careful, and one more. So how many?
10.
10. So 9.0 times 10 to the 10th. All right, let's do some small numbers. Okay, so this time I'm going to go the other way because the number's small. See, when the number's big, my exponent is positive. See, this decimal place right here is 10 to the negative 1 because it's the tenths place. See, the tenths place. And this decimal place right here, that's 10 to the negative 2 because it's the hundredths place, right? And this is the thousandths place you learned in elementary school, or should have. That's 10 to the negative third, which is the thousandths place. So hopefully you remember doing that at some point. So we want to do now the same thing, but it's going to be negatives. So what's the important part? Well, this part right here. So I'm going to write that as a number between 1 and 10. So that's 7.5 times 10. Now I'm going to count the other way. So now I don't have any commas here to help me, so I am going to have to just one at a time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went back 9. So if I go backwards, smaller, in the smaller direction, it's negative. And if I go forwards, that's a positive. You with me? I guess so. I didn't hear anyone say anything. All right, what would that one be in scientific notation? What are my important numbers? Ryan?
2, 5, 8.
2, 5, 8. And I'm going to write that as a number between 1 and 10, which would be
2.5.
Yep. Times 10 to the, now we need to figure out how many spots we moved that decimal point. So I moved it all the way over here to there. So that would be 1, 2, 3, 4, 5. 1, 2, well, that's why I do home counting. 1, 2, 3, 4, 5, 6. So I can count because I can't count. Negative 6. There we go. Any questions how to do that? Okay. In that case, if there's no questions, I'm going to write two numbers up here that someone tried to put in scientific notation but failed for some reason or another. All right, Trey, so the first one, there's a problem. Why is this one wrong?
Decimal needs to be in between the 5 and the 3.
Yeah, this is not between 1 and 10. All right, so this decimal point, Trey told us, should be right here. It should be right here, where I'm putting that little caret. So correct, it would be 5.36 times 10. Now I've moved it another step, right? I moved it one more to the right.
It should be 9.
So it should be a 9. All right, now you try. In your notes, go ahead and try. I'll do another one like this that's wrong. That's a 12, by the way. Go ahead and fix that one. Fix it. Make it right. All right, what should it be? Or where should the decimal point be? Let's start there. It should be 1,
0.64.
and we can also take the 9. Times 10. Now, I took my decimal point and I pushed it further up, right? Twice. So the exponent should be a what?
14.
14. All right, now this one's wrong also. For the same reason that this one's wrong, it's not a number between 1 and 10, but look, I have to back my decimal point up 1. So it's 4.2 times 10. Now if I backed it up 1, I should decrease my exponent and it should become, as Trey is holding up, a 2. Fix this one. Alright. Where should the decimal point be, Rachel?
Should be between 7 and 8.
So 7.83 times 10. Now I've backed it up. How many times? I'm seeing a bunch of people hold up a 2. So what should this be? A 2. Okay, not because I backed it up 2, but because I decreased that by 2. Any questions on fixing them if they're wrong? Okay? In that case, let's go the other way. We're going to write each of these in standard notation. So these are in scientific notation. All right, so here's how I would do this. Just watch how I do it. All right, I know I'm going to need to move my decimal point. So this is a positive exponent, so I expect the number should get big, right? It should get bigger. So I'm going to move my decimal point so it gets bigger because that's a positive. So watch how I do this. Here's my 9. Now I'm going to start counting decimal places. 1, 2, 3, 4. Let's see, 1, 2, 3, 4, one more, 5, right? I start writing, so my decimal point's right there, because I moved it. And that's my answer. I could put a 0.0 there if I wanted. Not necessary. So how about this one? I need to move that decimal point how many times?
8.
8. So watch, 3. Now I'm going to start counting. 1, 2, 3, 4, 5, 6, 7, 8. Now it's right there. Okay, now I'll double check. 1, 2, 3, 4, 5, 6, 7, 8. Just, it would be a shame to get these wrong, right? I don't think they're that hard. Easy points on your test. And what about that last one? I don't know why students find this one tricky. It's just times 10, right? So, boom. Easy,
Whoa.
right?
Yeah.
Right.
Hold on.
Or I moved it one spot.
No, it can't.
Am I dumb? I'm
Yes.
dumb. It's just times 10. 51.
You
See, I'm dumb.
Jesus
I got it wrong.
Bull.
I got it wrong.
Bull.
Look at that. See, it'd be a shame to get these wrong. Look at that. Look at
Grade
that.
A teachers.
Okay. So those were the positive ones. All right. You tried each of these. Write them in standard form.
Hey, can you lunch for lunch today?
Food of some sort.
Vegetable soup.
What is it?
Vegetable soup.
Really? I bought that.
I'm
No, I
disgusted.
like your vegetables. Write each of these in standard form.
Yeah.
Trey, you got them? You done?
I'm working on it, King.
Making sure, keeping you on it. I wouldn't want Rachel to have to, get on your case.
She does that anyways.
Someone has to. Alright, so the first one, 1, 2, 3, 4, 5, 6. And just for ease of reading, add our commas there. The next one, 1, 2, 3, 4, add our comma. Any questions on that? We good? Who got them right? Both of them right. Good. We know stuff. Alright, let's try negative. So we're going to write in standard form, but we have negative ones this time.
What form is this?
We're going to, well, I give it in scientific form. We're going to write in standard.
Optical.
Okay. Now, when I'm moving, pay attention up here. Let's compare and contrast these two. All right. So notice this one's the positive exponent. Now notice with the positive exponent, I'm moving my decimal point back to the right. I'm going that way. So watch how I count. 5 and then 1, 2, 3, 4, 5, 6, 7, 8. You know, I started at the left and went to the right. Now this time, because that's a negative exponent, that means my number should get smaller, right? This is a smaller number. So I'm going to move my decimal point to the left because of that when I get it to standard form. And I'm actually going to start counting from the right. Here's my 7, my 3. Okay, now I'm going to have my 5. So 1, 2, 3, 4, 5, 6, 7, maybe an 8. So let's make sure I did that right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so right there. Okay? Same idea. So this 3, all right, so I write my 0 at the right. 3. I'm actually not going to need that. Okay, so see, I moved it. So that's 1. I start counting there. 1, 2, done. Okay, I moved it twice. 1, 2. You with me? And the last one. So there would be a 0 there. So I write my 5. Okay, so the decimal point was there. 1, 2, 3, 4. Okay, for whatever reason, it's the counting that gets us, messes us up. All right, you do these two examples in your notes. See if you can get them. Okay, do those two examples in your notes. See if you can get them correct. And then we'll be on the last thing. And it looks like we won't have time to practice too much. But hopefully you don't need that much practice on this, right?
Yeah.
Does anyone need extra practice, just be honest?
Yeah.
Okay. Wrap those two up. And we can go ahead and get these. You're like dancing all the time, Trey.
I love dancing.
Like, when you're asleep, do you dance? Do you dream of dancing?
Well, I'm asleep, so
Yes.
I wouldn't know.
Oh.
I know I talk in my sleep though.
Amber talks in her sleep a lot.
My sister will sleep all day.
One time I saw myself guinea pig.
One time Emma sat up and she said, "Thank you for caring about the mustard king." I don't know if she meant thank you for caring about the mustard king or thank you for caring about the mustard, comma, king.
My sister at the wall.
I think the
Are you
mustard
saying that when
king-
she talks in her sleep, she doesn't punctuate her sentences?
She said it as one fluid sentence. I had no idea what it meant. She also sang Jesus Loves Me, or like something, Jesus Loves Me remix one time.
Whoa.
Okay.
Kind of terrifying.
This one. All right. So watch how I do. Now I'm not counting these first two because I don't have to move my decimal point for the first two. So now I start counting 1, 2, 3, 4, 5, 6, 7. There's my decimal point, and I just want to make sure I'm not a bonobo.
Too late.
So 1, 2, 3, 4, 5, 6, 7. Because I don't want to get these wrong, like I did on the 510/51 answer. All right. So we're on the last thing. Multiplying.
Amazing.
Saved your phone.
Okay, here we go. Let's say I have 4, and then in here I have 3.5 times 10 to the 6. Okay? All I have to do is distribute. Now, I only distribute it to one of these things, not both of them. So I'm just going to multiply the 4 and the 3.5. So what is 4 times 3.5 from your calculator?
Wait, why wouldn't you do, what?
I'll explain in a minute if you don't understand why we don't.
14.
Okay, so we get 14 exactly times 10 to the 6. Now, remember close to the beginning of class, is this in scientific notation?
Yes.
No. Okay, because my decimal point's here, I need to fix it. So I need to move it one more spot. And since I moved it to the left, I'm going to have to go ahead and, what should that 6 actually be? 7. Okay? Let's try another one.
Wait, why would, do you not have to solve it?
There's nothing to solve. You mean write it out in standard? No.
Yeah.
I'll leave it in scientific.
Hold on. Stop! It's about to give me a seizure. I'm struggling.
Okay, how about that one? What should we do?
Multiply.
Okay, so when I multiply 6 times 7.49, what do I get?
44.4.
44.94.
And that's still times 10 to the 5th. Do I need to fix it? Yes or no? Do I need to fix
Yes.
it?
Yes.
Yeah,
Yes.
I need to move it one more spot. So it's 4.494 times 10 to the what? 6. All right, any questions on any of that? Going once?
Wait, don't erase it, please.
I'm just going to stop.